Factoring a GCF. Whenever we're factoring any expression, whether it be a binomial, a trinomial, or a polynomial, we always start with trying to see if that polynomial has a GCF. GCF stands for greatest common factor, and that means I want the largest number and letter that fits into all terms. And I'm going to pull that guy out, and I'm going to write it as a product. So let's take a look at the first example that was on the cover, and that example was 5x squared plus 15x. So in this example, as in all examples, we're going to take a look at the numbers and the letters in this problem. So in 5 and 15, the largest number that fits inside of both is 5. So I'm going to go ahead and pull that 5 out. Now, when I look at x squared and x, I'm thinking of the most amount of a variable I can take out. So x squared means x times x. And x is, of course, just x. So I'm thinking, what is the largest amount I can take out of each of those expressions while still being fair? And the answer is x. So if I'm going to divide out 5x from both of these expressions, I'm going to then write what's left over. So 5x squared divided by 5x, my 5's reduce, and where I had 2 x's, I'm pulling one out, I am left with just 1x. And in the second term, I have 15x. I am pulling out a 5, which will leave me with a positive 3. And since I only had 1x to start with, and I'm pulling that x out, I am finished. There is nothing remaining. Those x's reduce. So that means I can write this as a product, 5x times x plus 3. Let's look at one more example. How about we take a look at 18 x to the 4th plus 6x squared. So in this situation, I have these two numbers here. I have 18 and I have 6. So you might be thinking 2 goes into 18 and 6, and it does. 3 goes into 18 and 6, and it does. But I want the largest number that goes into both. And the largest number that goes into both is 6. So I'm going to pull out that 6, and I'm going to make sure I divide it from both expressions as well. So I like to put it all at once just so I don't forget. Now I'm going to take a look at my x terms. Here I have x to the 4th, which means I have x times x times x times x. And over here I have x squared, which means I have x times x. So if I wanted to say to myself, well, what is the most I can pull out from both terms and still be fair, the answer is 2. I can pull out 2 of those x's, so that would be x squared, the product of 2 of them. Now I'm going to pull out that x squared over here, and then when I write what's left over, I'm just dividing. 18 divided by 6 is 3. If I have 4 x's and I pull 2 out, I have an x squared left. Now over here, my 6's reduce and my x squareds reduce. And we want to be really careful here because we're not done. You still have to put plus 1, because when something is divided by itself, it's equal to 1. It's not just disappearing, so that expression is equal to 1. Now, if you would have pulled out a number smaller than 6, thinking you did a good job, you would have noticed that in here, there's still a common factor. But if we take a look at 3 and 1, there is no greatest common factor other than 1, so I know that I'm completely finished, and this has been factored completely. Stay tuned for more lessons on factoring, including difference of two perfect squares and trinomials.